Hello and welcome to another one of my videos. In this one we're going to be looking a little bit at engineering again. Over the last year or two I've been looking at gears. There's some amazing concepts in gears. You have a central point and you take directional energy, and because of that point it converts it into rotational energy, and then with the teeth between there you can transfer that energy from one to another, and you can do some amazing things like make motors and engines and all sorts of things with that basic concept. I've also been looking at clamps, and I've used cam clamps and wedges and all sorts of things as they used to in the past to secure things. But I was thinking, what happens if I was way out in the middle of nowhere and I needed a vise to be able to do some woodworking out in the jungle or something like that? What is the main component of a vise? It's a screw, and there's some amazing principles or concepts in the screw that you can do. So I started playing around with it and to take a look at the concept of screws. Gears and screws have some very similar concepts, but also some extra concepts. They both have a central point where it's going to rotate around there, and it's going to transfer the energy through teeth. But a big difference between a gear and a screw is that the screw only has one tooth, and it will mesh this way. And where the gears transfer the energy by pushing one tooth on another, the screw slides through between the teeth. There's a push compared to a slide, and also it's oriented in an opposite way, a 90-degree there, and therefore the tooth also has to reorient, so it slides through like that in its rotation. Also, it is a little longer, so it's a cylinder rather than a flat disc, and the tooth therefore is the same profile, but it is a lot longer, and it's going to stick on there okay. And being longer, it's going to wrap around the cylinder, and instead of meeting up with the same point here, it does an offset. Once it spins right around, it offsets, so that the point of contact where it's sliding against something else, as it turns, the point of contact slowly, very slowly moves across until it is in another position. And then you can take that as it goes across like that, and then you can continue it so that it goes around and around and around until you get something like this. So if you have a hole where your screw is going to go into, and since it only has one tooth, you need at least one point of contact that is going to go on the same angle of the offset so that they will come into contact. And as you turn that, the rotational energy of the screw, or in the screw, is then converted to sideways motion in a very precise manner. But that's basically the minimum you need for the screw to work, the tooth and at least one point of contact. Now, one tooth with one point of contact is the minimum that you need for that to start working. But it's not very strong because everything's concentrated on that one point, and that can break and slip and do all sorts of things. So one way to improve that is increase the contact of this tooth with your other tooth, and by doing that you can do it like this. They look like more teeth, but it's really only one, because the point of contact as it rotates pulls it through. There is more contact with this tooth, and so it is a lot stronger. We could increase that contact by not only having teeth on the two side ones, but on a lid and a base on the top, by making some grooves with the offset angle on the top and the bottom. And that will make it a lot better, and it will be a lot stronger also. Now, I have clamped this to a work table and put a thing on there, and it is actually strong enough to hold a small piece of timber for planing, but that's working a lot better. But probably best of all is to have a hole and have a tooth similar to the screw continuously going right around the inside of that hole, so that when the screw goes in there, it's going to wind in. It has maximum contact and is the firmest of all. So let's make a screw using a broomstick. So we're going to measure the offset. Let's just pick a random number like 1 centimetre and mark off 1 centimetre increments up and down the pole. Then with a piece of paper, I'm going to start on one of those marks, wrap the paper around so that it then coincides with the next mark, and that will give us our offset. Then stick it with some tape or glue. So now I can use the paper as a ruler to mark a line right around so that it joins up with my first mark, and then move it along to the next one and repeat. Then with a saw with a depth stop, and I'm going to cut along that line. So it's finishing like that. Then I'm going to draw a line in the middle of that as the tip of the tooth, and the cut is the gully of the tooth, or the valley. Then with a knife, from that line I'm going to go down for one side and back the other. And then back the other way. So there we have it. It seems to be functional. Now let's make a thread to make it useful. So I'm going to take a couple of sticks there that are going to be my teeth, and it's going to be tall enough so it will go through like that, and then line it up, and I'm going to draw where those teeth are going to go. They should be 1 centimetre, but this is to get the angle. And then with a piece of paper I'm going to get that angle and bend it like that, but I'm going to bend it the other way to be able to get me the angle from here going back in the right direction, which is there. And then I'm going to saw it with the saw like before, and with the knife and everything as before. And there we have it, just to try it out. Now you can just clean up those teeth so that they mesh properly, but there it is, functioning more or less properly. So there I have it clamped with a lid on, just for demonstration purposes, and there it screws in. And it's quite solid. So now let's make one of these ones with a hole with a thread. But in order to do that, we're going to need to make a tool to make that thread. We are going to need a stick that is the thickness of the inside of the screw, not the tips, the inside, so it's going to be a little bit smaller. Now I'm going to cut a flat and then I'm going to put a screw through there so that it is just poking through the other side. Now from that point there, I want to mark out the same distance as the thread on my screw. I'm just going to 1 centimetre. And the same as with the screw, I'm going to do the same process of marking out those lines. So I'm going to repeat the screw situation. So it finishes like this, and then we're going to bore a hole in where we're going to put it, the same diameter as that. So that's going to fit in there. Now I've put a little block under here clamped, and I'm going to get a saw and run it on the same angle as those threads and saw it down into there. This is so that the blade on the smooth side is in the groove, and this groove, and when I turn it, it will pull it through and the screw will score a line, a thread through. Remove it and then screw that in a little bit more so that that pokes out a little bit more, and slowly but surely grind a thread out. Keep going like that, screwing that screw in to make that thread get deeper and deeper until you can get your screw to screw in nicely. Very nice. And there we have it.